In the process world, you want to invest in the best available measurement equipment, giving you the opportunity to deliver the highest quality product to your customers. You've got a tough job with a lot to keep track of. Assets, quality, safety, environmental concerns, all of which rely on transmitters to provide reliable measurements. Transmitters are designed to work in the harshest environments. But what happens between the devices and the control room? There is more to your loop than just your transmitters and control elements. The critical measurements that you rely on cannot be sent back to your control room without the proper loop infrastructure that includes the actual loop wiring, junction boxes, cable trays, marshalling panels, and other components. Over the life of your plant, these critical components of your loop infrastructure are subjected to a variety of environmental and human stresses that can put the reliability of your 4 to 20 milliamp control loop at risk. What are some of these risks? Wires can become damaged or corroded. Water and condensation can find its way into housings and conduit. Power supplies can deteriorate and become unstable. Grounds and electrical shorts can inadvertently be introduced to the loop. All of these issues can impact the integrity of your 4 to 20 milliamp loop, causing the control room to receive inaccurate measurements and potentially lead to dangerous on-scale failures. Let's picture two scenarios which can lead to on-scale failures. The first scenario is a circuit that has leakage current, which is an electrical issue where an additional current path is created in the wiring. Leakage current can be caused by a number of human or environmental factors, including corroded terminals, water in housings or conduits, shorted wires, and others. Let's assume that leakage current has been created due to one of those factors. This additional electrical path causes there to be a discrepancy between what the transmitter is outputting and what the control system is receiving, resulting in an on-scale failure condition where you could be taking control action on bad information. In this example, the control room is reading 18 milliamps even though the transmitter is outputting 15 milliamps. The second scenario is an increase in the electrical load of the wiring loop. This can be caused by corrosion, a failing power supply, human error, or other environmental factors. In this scenario, the electrical loop was designed to have 500 ohms of resistance. When additional resistance is inadvertently added to the control loop, the reliability of the control loop is compromised. With an increased wiring loop resistance, there may not be enough voltage for the transmitter to drive the loop to the proper milliamp value or even to an alarm state. In this example, the transmitter is unable to go above 16 milliamp. You don't have the time or resources to perform regular manual loop checks, so you won't know that there is an issue until it's too late. If the milliamp signal is not being conveyed accurately, you may be making adjustments to final control elements that are not required, causing bigger problems. You also may not be able to bring your process to a safe state because you're unable to reach alarm levels. What if your transmitter could detect all of these changes that could impact the integrity of the 4 to 20 milliamp loop? Rosemount pressure transmitters with loop integrity diagnostics continuously monitor the electrical characteristics of the loop, including changes to the voltage and resistance, allowing you to be alerted to these conditions before they can cause an on-scale failure that may put your process, plant, and people at risk. This new capability is called Loop Integrity Diagnostics. It is available on Rosemount 3051S and 3051 pressure transmitters. To learn more about Loop Integrity Diagnostics, contact your Emerson sales representative.